Welcome to this comprehensive tutorial on variables and data types in Java. And in this video, we're going to cover everything you need to know about the fundamental concepts, including a few updates that have been made to the latest versions of Java when it comes to variables and data types. So, shall we begin? All right, so we're going to talk about reference types and variables in Java. So I'm going to begin by explaining what exactly is a variable in Java, all right? So in Java, a variable is a named piece of computer memory that can store a value. When you create a variable in Java, the computer sets aside a small amount of memory to hold that variable's value. And there's two main types of variables in Java. There's a primitive variables and there's a reference variables. Primitive variables are used to hold simple values like numbers, characters, or even booleans. And you can only store one value in these primitive variables, whereas a reference variable is used to hold more complex values like an object, and an object can have different properties and methods, associated with that object. So let's just explain that in depth more. So let's start off by explaining a primitive variable, right? And when a primitive variable is created, the value is stored in the variable and directly in that variable's memory, right? So the computer sets aside a little bit of memory space for that value, and it stores directly in that memory region, right? And it's stored in a special region of the memory called the stack. This is where the primitive variables are stored, right? And this is like having a box that can only hold one thing at a time. And the value is stored directly in that box, and you can access it very quickly, right? So I have this chart over here, or this like diagram and example. So you can think of this stack as like a stack of boxes or a stack of cards, where when you pick from the stack of boxes or the stack of cards, you usually pick from the top of the stack of boxes or the top of the deck. And this is associated with a removal pattern, which has its own acronym when it relates to stacks, called last in, first out, or LIFO. And you'll see this a lot in computer science and just in programming in general when we're talking about the stack. That's the structure that it follows, or that's like the pattern of how it removes items from the stack that it follows, right? So you can see in our stack, we have like a hypothetical set of values. We have a race complete, which is, a true value. This is a Boolean value, so it's equal to true. We have height, which is a floating point value, which is equal to 1.6. And I'm referring to like 1.6 meters. And then we have age, which is 25, right? So in Java, the stack is a data structure that, stores primitive variables directly, allocating memory for them in a last in, first out manner. And the stack is used to manage and keep track of these variables during program execution, allowing for more efficient memory allocation and deallocation, right? So memory allocation, deallocation, that's just basically the way, Java handles memory when creating, memory for variables, whether it be reference type or primitive, and deallocating how it cleans up that memory that's no longer being used. That's what basically that means in a nutshell. All right. So let's move on to reference variables, and I have a little diagram to kind of explain and sort of like, give you more of an insight of how reference variables work, because they're a little bit more, I'd say complex, but not too complex. So on the other hand, when we talk about reference variables, when they're created, the value is actually in a memory address, right? That points to where the object is stored. And this memory space is typically in a different region of the memory called the heap. And this is like having a bucket, like I've drawn here, that can hold an address. And the reference variable holds the memory address of that box or that bucket where the actual value is stored. Okay, so I'm going to explain this, right? Because this diagram explains how different memory locations in Java kind of store primitive and reference variables, right? So you can see that bucket with the primitive variable. It has one object or one, not object, sorry, I don't want to confuse you, because objects here is, the toy, but objects in Java mean something totally different. So I'll just say one toy, right? One toy stored in that bucket. And that's one type of toy. It's a Santa Claus toy. It can't hold anything else, right? So that's a primitive variable because, it can only store one value. It's stored on a stack and it's, can be accessed very quickly. So yeah, that's like, that's basically what a primitive variable, how it's kind of structured. But a reference variable in the bucket, right, on the heap, you have a memory address, and that memory address is basically an address to where the object is stored. So instead of having, direct access via that sort of memory space, the memory space is actually holding an address, and the address points to where the object is on the heap. And as you can see, a reference variable can store many different types of data, whereas like a primitive variable can store one piece of data. An object can have methods, it can have properties, and the properties can be of several types. It can be of a string, it can be of a Boolean, it can be of an integer. So you can have different toy types, just like here in this diagram. You have a Santa Claus toy, you have a globe, you have like elf toy, and you got like a cookie, and then you've got a bunch of other stuff. So think of that as a reference type. A reference type can have various different types of data, including operations like methods. And a primitive type can only have, or a primitive variable can only have one piece of data of one type, which you declare, right? So moving on. And basically I just, there's the analogy that I wrote. This slide is actually supposed to be before the last one. But so I just, want to explain it more in depth here. So like imagine you have a bucket that you can hold different things in, like toys and snacks. And when you create a variable in Java, it's like putting something in that bucket, right? And primitive variables are like putting a single thing directly into the bucket where it's easy to see and reach. For example, putting a toy car in the bucket, right? Reference variables, on the other hand, are like putting a note in the bucket that tells you where to find something else, like a bigger bucket of snacks and toys. So the note has the directions to the bigger bucket, like look under the table or go to the kitchen. And this way you can follow those directions on that note and find the bigger bucket to play or eat from, or whatever you want to do, right? So when you create a variable in Java, it's like putting something in a bucket. And primitive variables hold a single thing directly in the bucket, while reference variables hold a note with directions to where the bigger bucket can be found, right? So that kind of explains that last picture here. With the buckets and the primitive variables and the reference variables with the notes. So that's kind of what I was talking about. So moving along. So we have this chart here, and this is basically for primitive variables. And I'm going to take you to the IDE and show you how to create each of these, right? But these values are good to know so you know what the capacity for each one of your primitive types are, because in Java, it can, depending on the type, right? And as you can see here, it can only store up to a certain, capacity of values on the negative and positive side for numbers and shorts and longs and whatnot. And, a certain, amount of bits for other types like a float or a char or a Boolean, right? A Boolean is just one or two values, right? It's true or false, 0, 1, right? Whereas let's start from the top down, actually. So a byte, that represents 8-bit signed integers. So basically anything from -128 to 127. So when you set aside a byte, you can't declare it anything above 127. So 128, you're going to get it like in a, what do you call it? You're going to get an error within your IDE, which will warn you that, hey, you've allocated this memory to be byte, but you're storing more than what a byte can handle. Something like that, right? And then you have a short, and a short represents a 16-bit signed integers from negative 32,768 to positive 32,767, right? And you have an int, which is 32-bit signed integers from -2 to the 31st power to +2 to the 31st power -1, right? And you got longs, 64-bit signed integers from which is basically a double of that of last value, -2 to the 63rd power to +2 to the 63rd power -1, and so on and so forth. You got your floats, you got your doubles, you got your chars, and your booleans. If you look this up, you'll find this online. I don't want to be too long-winded, but this is basically what each of these values are capable of storing. So, you know, just know that if you want to store larger values, you might need a long, like, in the millions or so, you might need a long. But if your values are like for a couple million or less or so, you can use an int. And if they're really small, you don't think they'll probably be above 20,000, 30,000 on a positive or negative end, then you can use a short. And if they're really, really, really small, maybe not more than 100 on each side, maybe not more than negative 100 or not less than negative 100 or not more than positive 100, then you could probably use a byte to save yourself some memory. Because if you know, like, for instance, right, if you know the data type is going to be something less than 100 or like not even, it might not even be negative. For instance, the months in a year, there's only 12 months in a year, so you don't need to allocate an int for 12 months. You could probably just allocate a byte so as to save memory in your program. So something like that. So these are the things you're going to have to consider when you actually start programming, and programming for companies or building applications is just memory and how to allocate memory and how to declare variable types and stuff like this. So this stuff is kind of good to know. All right. So yeah, I'm going to take you over to the IDE. That was the last slide. I'm going to take you to the IDE and I'm going to show you in IntelliJ how to create these different types of variables, as well as how to create reference type variables. I'm going to show you the most common type of reference types that you'll see in Java working with, applications at work or whatever. So let's go over to the IDE. All right, so I'm over in my IntelliJ and I'm just going to create a new class for variables. And I already have like a bunch of um I have like a bunch of things like kind of pre done. Hope you guys can see this. Uh Let me just go over to my notes. I'm going to just copy and paste this here just to save time because I have a lot of examples to show you guys. So we're going to start with the primitive variables, and I'm going to be referring to that chart. So here we go, right? Let me just paste this here. All right, hope you guys can see that. So yeah, this is basically the primitive variables that you would see in Java, right? So you have your byte that I said goes from minus 127 to or minus 128. Let me actually refer to the chart so to be sure. So yeah, minus 128 to 127. So what happens if I type something like 128 here? Like I said, you're going to get that error, or 129. You see that? You got that error. Now let's check out what that error says. That says migrate to an int or cast to byte. Well, what is basically saying, hey, you've gone outside of your byte boundary, so you might want to consider using an int, which you can do automatically just by coming down here. If you're IntelliJ, at least I can only speak for IntelliJ. And then you can click that, and then boom, it changes to an int, and this is fine. So let's just undo that and switch this back to what it was. I think it was like 10 or something. Yeah. So that's what's going to happen if you exceed the boundary for a byte, right? So if we go back to that chart, a short goes on the low end from minus 32,768 to positive 32,767. So what happens if I go positive 32,768? Boom. Again, we get that error, and you can check errors here on the right as well, and it'll give you sort of a more comprehensive view on the bottom of your error. So yeah, it says incompatible types found int required short, right? So you can also view errors here on the left by clicking that line here, and it will show you required type short provided an int. So it's basically saying, hey, you said that you wanted this s variable to be a short, but you provided me something that's outside of the bounds of a short and would be considered an int, right? So let's just see if we even gave it like a long. So that's like what? Positive 263 to the minus 3 power. So like if we just keep adding numbers to this, right? You'll see that sort of changes. It's too large for an integer. integer number too large. You see that. I'm just trying to make sure it's like it gets to like a. Let me see if it gets to n. Right. So yeah, it has that message again where it's like in the bounds of an int instead of like a short, which is a 32,000. So let's just change it back to whatever. Right. And yeah, we have int. We do the same thing for all these other numbers. We're going to get like similar error messages. Right. But yeah, as you can see, even here down with a character, you add another. It says too many characters in character literal, so you literally can only add one character for a char variable type, and a double. You pretty much can have these like doubles and floating point numbers. You can have decimals as your value, right? The thing about floats is with floats, for floats, you need to add an F as a suffix to the value to indicate that it's a floating type. Similarly, for longs, up here you can see there's an L here at the end. For longs, you need to add an L suffix to the value to indicate that it's a long, right? Or else, like if you specify the type as long or a float, and you don't have, did I do something there? Yeah, so if you specify the type as a long or a float and you don't have this uppercase L for long and this lowercase f for float, you're going to have an error there. So, make sure if you want to indicate a long or a float that you basically have these suffixes there. So that's another important thing to note. And Boolean can only have one or two values, which are true or false. Those are like truthy and falsy type values. So you'll see that a lot. And also, all of these types have a corresponding object wrapper type, right? So you'll see they'll usually be like in their classes because they have properties and other methods as well, like that you can have like the actual value that you store there. Then you have other methods and things related to that value. Like I think the char, like it has character, so it would be like uppercase C and then character, and then you have other methods on it. Like I think there's like toString, and then there's like other methods that are available on that character type because it's an object. It's not a primitive variable that can only store one value. But I'm going to show you reference type variables here in a minute. All right, so I'm in my main class because you can't really add methods in which you can execute immediately in your other classes. So you have to go to your main class because that's your entry and exit point of your application. So you can add methods which you can execute on the fly here. So what I want to do is I want to print out and show you different string methods just to show you that this is a complex type. You can't do methods or you can't run methods on primitive types, but complex you can. So with a string, you have a bunch of methods in which you can run, and you can go and check the Oracle docs and whatnot, and they'll tell you all of these methods. So I want to test out a few here. So there's a bunch of methods: trim, value of, to, char, array, substring, split. There's a bunch. I'm just reading from the list here. But I want to use one called ends with, right? So basically ends with will return a Boolean true or false if this value or if this string ends with a certain value. So I'm going to copy this, right? I'm going to copy this, or I can just, highlight this and just copy with the command. All right. And so I'm going to print out name, or I could just, use this here. Name, and then we're going to do dot ends with. Ends with, it should be populating. Okay, here we go. Ends with, and then you want to pass it a string. So you can either have a variable in which you declare before or just create a variable on the fly, like a string variable on the fly. So you can just say HN, right? HN, and this will print out either true or false. So we're going to see under this hello John, whether it's true or false, because and it should be true because this end was HN, so there's an HN here. So let's just run that and see what we get. All right, yeah. So I fast forwarded the execution. I don't know why my IntelliJ is slow. Might have to install Maven or whatever. But you see here, it yielded a true. And there's a bunch of other methods here. I'll probably just go through one more here, which is another method which returns a variable, returns a boolean. So it's called is empty, right? So you don't pass it anything. You just say is empty, and that's going to be either true or false. So let me just delete this. And then I run that, and it should be false. I'm going to get false down here under John because the name variable actually has some value in it. So it can't be true. As you can see, just like I said, it returned false because there is some value there, right? So next, what I want to do is I want to go and use the integer class, right? So I'm going to delete all this, right? And then I'm going to paste my integer class here, and I'm going to print this out. It should print out toString, right? See, the reason that's going to be in a string format is because the integer class has a toString method, and I want to show you other methods on the integer class as well, other than toString. But I'm going to run this because I've assigned this. This is the wrapper type, and this is the complex reference type that I'm talking about that has, properties and methods on it that you can execute, and there's a bunch. One of which is the toString, and I want to show you what happens. So I'm going to play that, and we're going to see what we're going to get. And also, while that's running, I want to show you another resource that you can use. Here is the Java sort of docs by Oracle, and you can see on the integer class, you have a bunch of methods like float value, equals, double value, all that other stuff. And this is a string value. We can't really tell because it didn't print it out. So I should really do something like this. Print out number toString. And then you'll say something like, I got a score of, and then you concatenate plus 10, right? Or what you could do is do something like this, right? You could add another string. You can print out, You can actually do this, which is, let me cut this out. String equals to string, let me say, result. Just say that, and then we take that out. So now we do system out that print line result, and that should give us, I got a score of number plus toString. So let me print that out. And as you can see, it says I got a score of 10, and that's because this is being turned into a string. So that's going to be the string representation of 10 instead of the integer representation of 10. And then you add these two strings together to make this complete string here. And then you print this out with the system out that print, and this is what you get. I got a score of 10. So like I said, if you go here to the Java docs, I don't want to make this tutorial super long. I just wanted to show you guys a couple examples. If you go here to the Java docs, and this is just integer, you'll see there's a plethora of methods that are available for you to use on an integer that can transform it, that can manipulate it in a whole bunch of different ways, get values and all that other stuff, hash code like values like this method, get hash code or hash code. And you can, basically use that to figure out or do or, do more complex things with whatever number you're storing here, with whatever integer you're storing here. So maybe you want to do things with this integer and you don't just want to store it, then you should definitely use a reference type. But if you just want to store it and reference it in other places and not do too many complex things with it, then use the primitive type, right? I'm going to go over a couple more here because they're interesting. Like I want you guys to check out this. This is a hash. This is a collection. So I'll teach this in later tutorials, but this is the array list and we have to import this here. So import class, array list, and then we're good, right? So right here you have, so don't be confused by this angle bracket thing. I'm going to explain this really clearly for you. In fact, let me give you a space. So yeah, this array list is basically a list of things, right? Whatever you want to put in it, right? And this angle brackets these less than and greater than signs that you just see this string value or this string class type here. That is indicating the type of values that are going to be stored in this list. And you can only store one type of value in this list, which you declare here, right? So once you declare this here and you give it a name and whatnot, you only can store string types in there, right? And like I said, complex objects, they all have properties and methods. And one of the methods here on the array list is the add. So we can add string types here. So I've added Alice and Bob, right? Now I'm going to print that out. The second name is get name. Remember, we start from 0 in programming. So the first value is 0, which is Alice. The second one is Bob. So it should print out Bob, right? So let me run this. And like I said, don't be confused by the array list type. I'm going to go over that in more in depth in later tutorials. I just wanted to show you what this value does, like, and what this class does actually. So now that it should be done, right? The second name is Bob. As you can see, even though we said 1 here, again, programming, labeling, and ordering starts from 0. So this is the 0th item, this is the 1st item or the first item. And so this is Bob, right? So moving on to another type of value called a hash map. And this is just basically using some sort of mapping to map key value pairs. And I'll show you that in a second. Right, and I got to import that class. So let me import that, give this a little space. All right, so just like the array list class type, the hash map, and if you hover over it in IntelliJ, it will basically give you a lot of information about it. The hash map can store values, right? And they're key pair values, right? So this is the key and this is the value, right? And this is ages. And you have to declare after that the equal sign, the new hash map. So you basically are basically constructing that type there. That's what that does, right? So you have the ages, you have this reference variable, and then you add values to it. Similarly to array list, they have a method in which you can add values, but it's called put instead of add. So you put the values of, Alice is 20, who's 25, and Bob, who's 30. You put that the key value pairs, the key, the string, integer is the value. Then you can come out and say system.println Bob's ages, and then you do ages.get Bob, right? So what that is going to do is just going, when you do the get, it's just going to get the value, right? So you're getting, this is the key that you're passing. So it's going to go iterate through that hash map and look for this key and then print out the value that is associated with that key. So let me just run that really quick. You should get 30, or Bob's age is 30. And as you can see, it has printed out Bob's age is 30, right? So those are a bunch of like complex reference types that you'll see in Java. Let me go over one more called, it's called string builder. So In Java, strings are what you call immutable, meaning like once you've created a string, you cannot change it. Like it's immutable. You can't change it. So that's what that term immutable means. So you'll probably see that a lot. Not even probably, you'll see that in programming a lot. So, right. So I have this string builder class, right? And basically, a string builder allows you to continuously add different pieces of strings to this string builder. And then you can actually just print out the string value of that final result by using toString. So you'll see, especially if you do things like leak code and other, things where you have to like kind of construct strings, or maybe you have an application that you're building or you're working on that needs to have strings constructed. So you'll probably use a string builder type to sort of add different values to that string over time and then like print it out at the end like I'm doing here. This is a very simple example, a very rudimentary example. I just want to show you just another reference type in Java, right? So we've created and we've instantiated a value here. We say hello, right? And then we use another one of those methods. Remember, I said these reference types always like they have these methods and stuff that you can, use to manipulate the values in them. So we're manipulating a value here. We're appending world to it. And now we just print out the string representation of that. We're using another method. So we're using a method here to append world, and we're using another method to change it back to a string, right? So let's go and just play that, see what we get. We should get hello world. And there you go. We got hello world, right? So there's a bunch of other reference types in Java. I just wanted to show you a few of them, because they're different from primitive types. Like I said, they have properties and methods which you can execute on them. And all these will be in the Java docs. So the Java docs are very helpful because they explain these methods and these classes in great detail, more than I can ever could in one video. So I just wanted to show you how primitive values and reference variables work in Java. They're essential to understand because these are like the building blocks of programming in Java. So I'm going to stop the tutorial here. I think that's good enough information for you. And I hope this was able to provide some insight and value into like how reference types and primitive types in Java work. So I hope you got value from this tutorial. Like, subscribe, comment with anything you have, doubts about or, questions about, and I'll make sure to reply as promptly as possible. All right. You have a good night.